Hello, Sir Parts online subscribers. Welcome to Sir Parts I Teach, and today we're going to learn about machine learning in W3 schools. And our next topic would be, yeah, our next topic is all about polynomial regression. Okay, polynomial regression. If your data points clearly will not fit a linear regression, a straight line through all data points, it might be ideal for polynomial regression. Polynomial regression, like linear regression, uses the relationship between the variable x and y to find the best way to draw a line through the data points. As you can see here, that is not a straight line. No? It is not a straight line. How does it work? Python has methods for finding a relationship between data points and to draw a line of polynomial regression. So the last one is linear, and this one is polynomial. We'll show you how to use these methods instead of going through the mathematical formula. So in the example below, we have registered 18 cars as they were passing a certain toll booth. We have registered the car's speed and the time of the day or hour the passing chord. The x-axis represents the hours of the day, and the y-axis represents the speed. Okay, that's the speed, the y-axis, and the x are the certain time of the day. And as you can see there, this is the code and the result, no, the resulting scatter plot. And we also have this one. Let's try to see the code, guys, if what's something something new here. Okay, so okay, just similar, no, it's just showing our scatter plot. And we will proceed to the next example. Okay, so this is now the critical moment for our polynomial regression. As you can see there, you have my model equals numpy.poly id numpy.polyfit xy3. So that's the critical code there for polynomial regression. Then you have my line equals numpy.linspace 122 200. So this would be the result. And these are the explanations. Import the modules you need. So we import numpy, we import matplotlib.pyplot as plt. Then we create the arrays that represent the values of the x and the y axis, where x equals. We use that 1, 2, 3, 4, 5, all the numbers, etc. Y and then all the numbers. By the way, the 1, 2, 3, 5 are the was that that's the value of the time, no, for the car that it arrived, and y is the speed. And numpy as a method that lets us make a polynomial model. This is now the polynomial model. My model equals numpy.polyld dot polyfit x, y, and 3. Then specify how the line will display. We start with the position 1 and end with the position 22. My line equals numpy.linspace 1, 22, then 100. Then draw the original scatter plot. That's the PLT scatter xy. Draw the line of a polynomial regression, plt.plot my line, my model, my line. And you're going to display the diagram using plt.show. R squared. It is important to know how well the relationship between the values of the x and the y axis is. If there are no relationships, the polynomial regression cannot be used to predict anything. The relationship is measured with a value called the R squared. The R squared values ranges from 0 to 1, where 0 means no relationship and 1 means 100% related. Python and the sklearn module will compute this value for you. All you have to do is feed it with the x and y arrays. So you have there the code. Okay. And the result 0.94 shows that there is a very good relationship. And we can use polynomial regression in future predictions. So predict future values. Now we can use the information we have gathered to predict future values. Example, let us try to predict the speed of a car that passes a toll booth at around time 17. To do so, we need the same my model array from the example above. how we predict the speed of a car passing at 17 o'clock. Okay, but let us create an example where polynomial regression would not be the best method to predict future values. So these are sample values, guys, for the x and y. And as you can see, somewhat like the linear regression, no? The line is it in the middle. Okay. Thank you very much, guys. And always remember, learning is lifetime. Bye, everyone. Thank you very much for coming. And we will have our next topic, multiple regression. Thank you. Always remember, learning is lifetime. Bye, everyone.